So we know that the dot product is if, let's suppose we have a vector u, which is equal to u1, u2, and we have a vector v, which is equal to v1, v1, v2, then the dot product u dot v is equal to u1 times v1 plus u2 times v2. Okay. So, just as an example, here are two vectors, u and v, and so here, let's say here this is u1, this is u2, and here's v1 and here's v2. So the dot product u dot v is going to be equal to 3 times 1 plus negative 2 times 2. And so we get 3 minus 2, which is going to be negative 1. And it's that simple. It's very easy to find the dot product. Just really quick, let's suppose I have two vectors in the ij form, the algebraic form. So instead, let's call this one example A. Let's see. So we have, let's say, for B, we have I plus 3j. So we have that u is equal to I plus 3j, and v is equal to 4i minus j. Well, it works the same way, except here, just remember that the numbers in front of I and j, those are going to be your components, the horizontal and vertical components. And so when I form the dot product of u and v, I only multiply corresponding components, so I have 1 here, right? So I multiply the I components, so 1 times 4, and I multiply the j components, so 3 times negative 1. And so we get 4 minus 3, 1. That's the dot product. Okay. Now, let's take a look at a theorem that uses the dot product. And sometimes it's called the dot product theorem. So the dot product theorem says that. So it says that if u and v are two non-zero vectors and theta is the angle between u and v, then u dot v is equal to the magnitude of u times the magnitude of v times the cosine of the angle between the vectors. Okay. So the reason why this becomes helpful is sometimes, let's suppose we know u and v, then maybe we can try to find the angle between the two vectors. All right. And so usually you might see the alternate version, so we can say also, we can say that the cosine of theta is equal to, just solving this right-hand side for cosine theta, dividing both sides by magnitude u and magnitude v, we get that u dot cosine of theta is equal to u dot v over the magnitude of u times the magnitude of v. All right. And so if we know the right-hand side u dot v and we know the magnitudes, then the only thing we need to do is take the cosine inverse of both sides, and we will get the angle. Okay, so here we have an example. I want to find the angle between these two vectors. Okay, and so I want to utilize the formula cosine theta equals u dot v over the magnitude of u times the magnitude of v. So we need to find u dot v, magnitude u, magnitude v, sub into this formula, and then take the cosine inverse, and we're done. All right, so let's start with u dot v. So u dot v, remember, multiply corresponding components, and then add and find the sum of those two results. So here we have 2 times 3 plus 1 times negative 2, and so the dot product here is going to be 6 minus 2, which is 4. Right. The magnitude of u is the square root of the sum of the squares. The magnitude of u is going to be the u1 squared plus u2 squared here for magnitude u. So if this is u1 and this is u2, then we get 2 squared plus 1 squared, right? And so that's going to be the square root of 5. And so for the magnitude of v, here we have v1, v2 right there. And so this is going to be equal to the square root of v1 squared, which is 3 squared, plus v2 squared, so it's negative 2 squared. And so we get 9 plus 4, that's going to be the square root of 13. All right. So now we have the information. Let's sub that into the formula. So now we have that the cosine of theta is going to be equal to u dot v, which is 4, over the square root of 5 times the square root of 13. And now we know theta will be equal to the cosine inverse of that, 4 over the square root of 5 times the square root of 13. Okay. And we get that this is approximately okay. Now what we're going to look at is another property here, and this property tells me that if I had two non-zero vectors, they're perpendicular if and only if u dot v is 0. Now the thing about think about an if and only if statement is that they are two directional, meaning that I read the statement in the forward direction and I can read it in the reverse direction. So what this property tells me, or theorem tells me, is that these two vectors u and v, if they're perpendicular, then I know their dot product 0. Also, if I know their dot product is 0, then I know that the vectors are perpendicular. Okay, so we can read it forward, we can read it backwards. Okay, so let's suppose I'm asked to show that the vectors, let's say u equal to 2i minus 8j and v equal to negative 12i minus 3j are perpendicular. So some people make a mistake by thinking that a picture is good enough. Now, when you're asked to show something, it's kind of like you want to prove something, and 99.9% of the time, or a lot of the times, not all the time, but a lot of the times, a picture is not good enough for proof. And they're so subjective. So, you might graph these vectors, and depending on how your scale looks, they might look perpendicular, they might not. So, a picture is not good enough to show that two vectors are perpendicular. The idea here is we want to show that from above, we know from this property that if I can show the dot product is 0, then those two vectors must be perpendicular. And it's not too hard to find the dot product. So here we can just check here. So u dot v is going to be 2 times negative 12 plus negative 8 times negative 3. And so here we get 0. So since u dot v equals 0, u and v are perpendicular. And just in case you forgot what perpendicular means, that means if I were to graph the two vectors, the angle between the two vectors is 90 degrees. Okay, so that will end this video. So we talked about how to find the dot product, and we looked at some examples of how we can use the dot product.